Businesses today are generating absolute oceans of raw information. Every click, swipe, and transaction is captured. Yet, when it comes to extracting actionable insights, that massive flood of data usually gets choked down to a tiny trickle. Over the last 20 years, the sheer speed and volume of information we can store have grown exponentially across almost every industry. Simply capturing that information is now standard practice. The companies that actually pull ahead are the ones that can efficiently take that raw material and refine it into usable business value. We have solved the problem of acquiring data. The real test is processing it fast enough to actually drive daily decision-making. To handle this, companies rely on the modern data stack, or MDS. The MDS is an interconnected suite of cloud-native tools designed to capture, process, and share data. This outlines the 5 pipeline stages. Information flows from ingestion to storage, through transformation to analytics and governance. Cloud automation makes ingestion and storage incredibly smooth, but right in the middle, at the transformation layer, the entire system often grinds to a halt. Transforming data, cleaning it, joining it, and formatting it for analysis still relies heavily on manual coding or rigid drag-and-drop tools. Operating these systems requires highly specialized data engineers. The result is a severe bottleneck. Entire organizations find themselves waiting in line for a small, centralized team of engineers to hand them usable data. To understand why this happens, we have to look back at the physical hardware of early mainframes. Before the cloud, companies hosted their own localized servers and tape drives, which had strict physical limitations. Because that physical storage space was incredibly expensive and highly constrained, engineers were forced to heavily filter and summarize their data before saving a single byte to the disk. This diagram shows the resulting framework, known as ETL, which stands for Extract, Transform, and Load. The transformation step had to happen first, right in the middle, simply to save space. This architecture was a necessary survival tactic for an era of scarce hardware. It was never an optimized framework for running complex analytics. Then, the cloud computing boom of the 2010s arrived. Providers began offering services that separated data storage from computing power. By decoupling the two, storing information became practically infinite and incredibly cheap for businesses of any size. This graphic illustrates how the acronym flipped to ELT: extract, load, and then transform. Data is loaded directly into a massive data lake, represented by Amazon S3. Companies dump raw information straight into the lake, delaying transformation until analysis is needed. But keeping everything creates a new problem. The sheer volume of transformation work required inside the data warehouse has multiplied. We cannot solve this processing crisis by simply hiring more engineers to write more code. The system itself requires a completely new engineering approach. The structural fix for this bottleneck is DaaS, or Data Architecture as a Service. DaaS is a framework where centralized teams create standardized data templates that anyone in the business can safely use. Traditional data transformation operates a lot like building a custom luxury car. Every component is handcrafted by a highly specialized engineer, making it high quality but extremely slow and expensive to scale. DaaS acts much more like modern mass manufacturing. Instead of crafting one-off pieces, you produce standardized, rigorously precise parts that can be rapidly assembled further down the line. Under this model, top-tier data architects do not write custom code for every individual request. Instead, they build reusable templates, known as data patterns. By treating data pipelines as a standardized product rather than a bespoke service, companies break their absolute reliance on a centralized engineering team. This diagram demonstrates a specific data pattern, like an SCD Type 2 table. This technique creates a new row every time a record changes, acting as a historical changelog. Here, it serves as a pre-built template for reporting needs. This interface shows true automation. To function reliably, these patterns must be metadata-driven at the finest grain, the individual column level. Because column-aware architecture perfectly tracks lineage from source to destination, anyone can safely pull a proven pattern and use it. Now, junior analysts and business managers can directly implement their own reporting requests without needing to write or troubleshoot advanced SQL. This asynchronous workflow removes the daily friction. the core engineering team is freed from a constant backlog of routine support tickets, allowing them to tackle larger architectural challenges. By combining the massive storage of ELT with the scalable assembly of DOS, the pipeline is finally unblocked. The work is decentralized, and the data actually delivers on its promise of business value.